Okay, raise your hand if you know what a frustum is. Let's find out. Okay, so here's an example of a frustum. And a frustum is basically a cone that's been cut off at a certain point. So in this particular problem, the problem says find the surface area of this. Okay, there is a formula for how to find the surface area of a frustum. The area of your top circle plus the area of your bottom circle plus pi times radius 1 plus radius 2 times the slant height. Now, if you want some first class math geekery, check out this video, which shows you how to derive this formula from the concepts here. But right now, this video is just a how-to. Okay, so we can simplify area of the top circle and area of the bottom circle by writing like this. Pi r1 squared, that's pi r squared, which is the area of a circle using our r1, plus pi r2 squared, plus, as we just said. And this formula right here is for like the wrapping paper to wrap that part of it. And this whole thing is based on the idea that you would find the surface area of the whole cone here and subtract away this top part, and you'd be left with this bottom part, and then you just add in your top and bottom. Okay, well, let's go ahead and execute on our formula here. So when we fill in numbers, that looks like this. So that's filling all of our numbers in, and then we go ahead and we start simplifying. And that looks like that. We put that all together to find 140 pi, or approximately 439.82. Okay, if all you care about is the how do I execute on this, you are done. If you want to stick around for a little bit of a proof that this is based on the idea of find the big cone, subtract the little cone, stick around. All right, here we go. Okay, so this drawing is not particularly to scale, but here's the concept. If we were to complete this cone and then drop this perpendicular straight through the middle, we have two right triangles that will be similar to each other. They'll both have right angles and they will share this top angle. So we know that similarity means we have proportional ratios. So 4 to 8 is our first ratio, and that will be the same as something to that something plus 5. Well, 4 to 8 is a 1 to 2 ratio. So these will also be in a 1 to 2 ratio, which means this top guy is going to be 5 also, because that will be 5 to 5 plus 5, or 10. Okay, now that we have that, we can find the sort of wallpaper of the first cone and subtract away the wallpaper of the little tiny cone. And the wallpaper of a cone is found with pi RL. So the big cone would be pi times 8 times 10. That's the big L. L is slant height, or 80 pi. And the wallpaper of the small cone would be pi times 4 times 5, or 20 pi. And when we subtract those, the wallpaper of the frustum, what's left, is 60 pi. And then we're back to where we started. We add in the area of this guy, pi r squared, and we add in the area of this guy, pi r squared, and we add those together, and that's our 140 pi. And so that is the surface area of the frustum. Okay, if you are a first-class math geek and you stuck around for this math geekery, put a comment down below. Let me know you made it. Check out some of these other geometry videos. Take a look at my geometry playlist. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.